Hey, have you guys heard about the new Parker Sporlan S3C case controller? Contractors, how about a case controller with a one-day setup, access to more data, and efficient system operation for the end user? The S3C series of case controllers provides contractors and store owners automated configuration and network integration. You can maintain precise food temperatures without supervisory control. Easily monitors to prevent product loss, and Bluetooth provides a local connection with the TechCheck mobile app. The series includes case controller display module, a valve supporting open protocol, communication via BACnet and Modbus. Sporlan's mobile app, the TechCheck, allows communication with the S3C case controller to enable proof of work, diagnostic, and data sharing. The S3C communicates with building automation systems and works with Sporlan's SPW series of pulse width modulation valves, also the SSR series of electronic expansion valves. Visit Sporlan.com for more information. Good evening, guys, and welcome to Advanced Refrigeration Podcast. You're here with your hosts, Brett Wetzel and Kevin Compass. What's going on this week, Kev?
Oh, nothing much this week. Just doing some, tidy up work at a couple jobs and just getting ready to go out of town to knock out another commissioning project next week. So it's kind of a slow week this week. Did some training at the shop with some CO2 on Monday. It was eventful, to say at least. And rest of the week, I kind of just bouncing out of some stores that we were doing construction on.
Sweet.
How about you?
So I got a COVID shot on Monday, and I was okay until like the afternoon, and then I felt like shit. And then that turned into feeling really, really fluey for the whole day of Tuesday. So I slept all day Tuesday. Wednesday, I slept most of the day up until about 11. I was like, I'll stay up for a couple hours and then I'll get a good night's sleep and I'll be straight for Thursday. I got a call from the construction department. We have a new case that we put in. It was like a service meat case with a gravity coil. The only difference is with this one, it has EEVs for the top coil and the bottom coil. And I don't think there was a superheat sensor or case temperature sensor or EEV sensor that was actually set up right, like where it was supposed to be, or just it wasn't where it needed to be. So one EEV was getting superheat readings for one case, another case was controlling EEV for the other one. It was just all over the place. And then on top of it, we had non-condensables because of a solenoid not being wired in from the factory for the shutdown, for the clean mode. So basically, we ended up finding that, and I've been doing office stuff all day, trying to engineer some stuff, and that's about it. So what are we doing tonight, man?
So we're going to talk about liquid pumped overfeed CO2. We're going to start. I figured this would be a great time to break into, CO2 and do a couple multi-part episodes on CO2. First part we're going to go over is going to be over subcritical liquid pumped overfeed CO2. Now, that's a really big term. Basically, this is the type of CO2 that you're seeing at Walmart and Sam's and some other retailers. So this type of CO2 is basically more basic systems. You still have an HFO or an HFC primary refrigerant cooling down the CO2. There's no CO2 compressors. We're just using plate and frame heat exchangers to condense the CO2 into a usable fluid that we could circulate around the store. This is the most basic type of CO2 system, and it was the interim into this whole transition in the U.S. This is what kind of started the flow moving towards CO2. I mean, it is the less efficient version because you're using a secondary fluid to cool something. So it's always going to be less efficient than using a primary fluid. like HFO or like just using CO2 in a DX application. So there's some nuances with it. So me and Brett are going to go over today on how it actually works, how to service it, and how to deal with some of the issues that arise with this that we've seen, and go over some like service type stuff. So with that being said, I'll break into like how it actually the system operates. So a couple main components I want to go over first. When we say vessel, we're talking about it is nothing more than a receiver, but we're calling it a vessel in this point. It is just a receiver with some different ports on it. So that is the only difference in this. It is a large tank with some ports coming off of it. Now we have. Go ahead, Brett.
I was going to say, you'll hear it referred to as a thermal siphon for any of you industrial guys out there. They have thermal siphon condensers that basically ensure that you have a full column of liquid at the bottom of there. There's usually some sort of line off the bottom to make sure that there's no air bubbles getting created when that CO2 drops down the bottom. Go ahead. That's all I wanted to add.
Correct. We're going to have liquid pumps. So we have liquid pumps that are going to pump around the CO2 around the store. Other than that, we're going to have a couple plate and frame heat exchangers that are going to be doing the thermal siphon. And the thermal siphon is actually how we're condensing the CO2. Brett, do you want to break into the thermal siphon since you got that more experience with the industrial side of it?
Sure. So basically the way it works is the thermal siphon receiver, the vapor is going to rise towards the top and the liquid's going to drop down to the bottom. They use this a lot in industrial refrigeration for the latent heat. For the latent cooling for oil systems on rotary screws. A lot of times, the liquid being generated off the drain leg off the condenser basically goes to a thermal siphon before it actually goes to any sort of receiver. So basically, ensures that it has, like I said, a full column of liquid going down. They use this on screw compressors on bitzer racks, TurboCool or something like that. Yeah, TurboCool. Basically, they have the same setup where they actually have a horizontal receiver on the drain leg before it actually goes down to make sure for their oil cooling. The reason why is because screw compressors, have so much. They produce so much heat because of the high RPM. So basically, you have to cool it down. But in this instance, we're actually using the thermal siphon, just to ensure that we have a full tank of liquid going to our CO2 pumps. Because like any pump that's pumping any sort of liquid, we want to make sure we don't cavitate the pump. And what that means is basically having air in the system. This will damage the pump. Because of these CO2 pumps are actually centrifugal pumps. They're all encapsulated. Depends on the size. I mean, they could be anywhere from 18 inches to almost 24 inches long. There's usually a primary and secondary pump that they usually do a lead lag program on. So basically, one day one pump's going to run 7 a.m. Or whatever time that the BAS is going to tell it to switch. It'll switch over to the other side. And like I said, if you look at the instruction guide on like the pump side, it tells you that it doesn't, it basically doesn't want a tank with just like a 3-inch or a 4-inch hole at the bottom just cut out of it. They want that piece of metal sticking up through. I forget how far it is. Every pump's a little bit different, but they basically want that piece of pipe sticking up through the thermal siphon at the bottom to make sure while it's actually draining that refrigerant from the bottom, it's not getting a Venturi effect where it's going to create any air bubbles. Essentially what that stack tube's for.
Correct. Now, the whole concept behind the way this is set up is you have these heat exchangers, okay? And they're going to have your primary refrigerant flowing through them. Now, that primary refrigerant is cooling down that heat exchanger. And it may be run like a minus 20 to a minus 27 degree evaporator temp. Now, what's going to happen is that CO2 is going to want to always go to the coldest spot. So that vapor off the top of that tank gets siphoned into that heat exchanger, and then it condenses from the heat exchanger being cold condenses back into a liquid. Then the liquid drops back into a tank. So it's this constant siphon effect. The CO2 always wants to go to the coldest spots. That's why it comes back to the vessel. Now, the pumps create a differential. So coming out of that pump, you should have anywhere from a 10 to like a 17-pound differential. Once you come out of that pump. Now, the way these racks are set up, if they don't see a differential, I believe it's 10 pounds, or anywhere from like 7 to 10 pounds. You're muted, Brett. If anywhere from like 7 to 10 pounds, they're going to lock out, and it's going to cycle on the other pump. And then once that pump fails, it's going to lock out both pumps, and you're going to have to physically go there. It wants to see that pump differential. If you don't have a full column of CO2, you're not going to have that pump differential. And those pumps will not run more than a few minutes without CO2 in them, and they will burn up. And they're like 10 grand. And if you burn up both of them, you're screwed, because if Hill Phoenix doesn't have them or Kaiser Warren doesn't have them, you're not going to be getting them anytime soon. They're going to have to come from Germany.
Well, hold on. I got something for that. So there's a company out of Houston, depending on the manufacturer. Because I had a similar situation happen where both pumps fragged. You are right. If there's no flow going through that pump, I had Armaflex burning, and that's how I figured out that the pump was bad. But there's a company out of Houston that actually has those pumps on the shelf. And you know, like I said, I lucked out because they were right in Houston, so I had someone drive up from Houston up to Dallas. But yeah, you can get them, but just you know, like I said, Google the manufacturer. A lot of times you can get it. You might be able to get them locally.
Yeah, I mean, if you get lucky like that, you guys got really lucky in that situation. I remember that night. Yeah,
So
that's not something that can happen. So as this liquid's getting pumped around the store, so we have a really easy control strategy for this. So we have our display cases, and we have our lines coming down that is getting the pumped liquid CO2 through them at like a 10 to 15 pound higher differential. So it's going down through the cases. Now it's going to hit a supply solenoid. This supply solenoid is going to cycle on and off via case temperature, just like glycol. So you have a dead band in a case controller, say it's like 2 degrees. So once it hits minus 10, it's going to shut the solenoid. And then when it gets down to minus 8, it's going to open the solenoid, and it's going to flood the coil 100% with liquid CO2. And this CO2 is going to absorb heat. It's going to boil off. So coming back, you have a liquid vapor mix coming back to the actual thermal siphon tank. Now, that CO2 has that differential to push it up, and it's also going to the coldest spot from that thermal siphon, because that tank is always going to be the coldest spot. So that CO2 always wants to migrate to the coldest spot. So every time it's going to want to go back to the vessel. Everything wants to go back to the vessel. Everything checks backwards in the store to the vessel. Every check valve, every ball valve has check valves around it. Everything always checks back to the vessel and the main reliefs.
One thing I wanted to add, you were talking about differential before with the pumps failing. So one thing that actually might cause, as far as a service issue that might happen, if usually off the bottom of the thermal siphon, it goes. You usually have a ball valve right there. You'll have a tap. It'll go into the pump. Then from the pump, it goes to a check valve facing towards, facing flow towards the outlet to the store. And then you'll have another ball valve for serviceability. So in case you need to change it out, you can. Now, if the pump check valve on the outlet were to fail. Okay, because basically what that check valve is for, usually those two pumps are piped in parallel. So basically, if you have pressure going out, and instead of if the check valve didn't hold, basically that pressure could potentially go back up into the thermal siphon. That's the reason for the check valve. So if that check valve would fail, there is a high probability you wouldn't have an accurate differential because it would, it's going to go path of least resistance, right? So it's going to end up forcing that refrigerant back into the thermal siphon, and basically, your pump might go off on differential at that point. Service side to check that, basically you could check your differential with one side, and see what the pressure is with one pump running, and then see what the other one's running. If the pump is still intact, it's pulling good amperage, but basically there's no flow, you can prove that by basically shutting off the ball valve to prove that the check valve that you believe is failed is in fact failed.
Great test. And the only way to know if these pumps are like spinning the right way is to tell from the amp draw. There's they draw like a half an amp difference when they're running the right way versus not running the right way. The higher amp draw, the pump is running the correct direction. The lower amp draw, the pump is running backwards. So you don't want to run it backwards for long. It'll burn the pump up. So the whole goal here is to not burn the pump up, because if you burn the pump up, you're going to have a bad time.
If you burn two pumps up, you're going to have a real bad time. It's reefer truck time.
Yeah, if you burn two pumps up, you're going to have a pissed off manager. So, now I kind of want to go over the HFC part of it.
Sure.
So what we're going to have a standard rack. You hope. There's some older versions of this where single units. We have 2 stores like that. They are absolute disasters. Where we have stores where they're single unit CO2 system. It's instead of a rack, they have 4 individual glycol cooled single systems, and they're doing the CO2. Yeah, it's a horrible system. It has nothing but problems, and it's one of the original Walmarts where they tried this at. But most of the time, you're going to have a 407A rack, and it's going to be a standard low temp rack. And what it's doing is it's just taking your liquid refrigerant, running it out to the condenser, comes right back in, and you're going to go to anywhere from 2 to 4 heat exchangers, depending on the store design. And you're going to have, hopefully, RCC 521s that are driving these EEVs. Some of the older stores may have Sporlan controllers. Depends on what you got. But so the way this whole thing is set up is they're trying to maintain 6 degrees of superheat, anywhere from 6 to 8 degrees of superheat on the outlet of these chillers. Now, looking at these chillers, I could usually tell if one's doing the right amount of work by looking at the EEV percentages. So one of these where it's set up and the liquid temp is at 30 degrees, because that's the target on most of these racks, 30. So they're subcooling it with the B rack from the glycol. So they're subcooling the actual refrigerant with the glycol. Now, once we have that 30-degree liquid, that valve should be anywhere from 30 to 40% open. Now, if you see valves that are like 10% open, 5% open, and you have high vessel pressures, then right there, that is a CO2 chiller that's not doing any work. So our whole goal here is to use this 407A rack. It's going to be controlling the CO2 vessel pressure. Now, the vessel pressure set point is anywhere from 205 pounds to 218 pounds. That's where it's going to be floating in and out. And it's going to be raising the rack suction pressure up and down and unloading the compressors to try to maintain that vessel pressure. So as that vessel pressure creeps up, it's going to increase the load on the rack. As it creeps down, it's going to start stepping up the suction pressure and then decreasing your compressor capacity. So a big thing to look at is if your 407A rack's running, you got liquid in it, you got a receiver level, sight glass is clear, you don't have plug dryers, and you have a high vessel pressure. So you need to go look at those RCC 521 controllers or the Sporlan controllers, and you need to look at them and see what your EEV percentages are in your superheats. So one thing to really keep in mind, which I've seen this a lot is you'll look at them and you'll have, the suction pressure will be like, say, like 15 pounds on the actual chiller controller, and you look at the rack and it's at like 7.5 to 6, and you're going to look at it and say, "Whoa, that's a big pressure drop." We've had oil like chunk up, and there is a inline heat exchanger right after the plate and frame heat exchanger for the CO2. There's an inline 2 1/8 to inch and 3/8 inline heat exchanger to add a little bit of heat to the suction line and subcool the liquid a little more. That heat exchanger has like 10 5/8 pipes in it, and that's how they create the vortex inside of it to subcool. Well, we end up getting nuggets of oil, frozen oil in there. That's all I could figure out they were. I've had guys say it's CO2. I don't think it's CO2 because we've ran all summer long without the rack's high heading, and I think any little bit of CO2 that got inside that rack would have caused nonstop condenser. So usually what we end up doing is we end up shutting down that heat exchanger, and we'll warm it up with a torch, and then all that's gone. And then you'll start it back up and it'll have no pressure drop. So that's one thing to keep in mind. Like if you have high vessel issues, and you need to check those chillers and make sure that suction pressure matches what the rack should be. It should be within a pound. Transistors, they fail all the time on those. They're not very good for the Novar side. So just make sure your transistors actually are reading what they actually are. And the same thing with the temp sensors. Make sure the temp sensors are actually reading. Same thing with the Sporlans. Make sure they're actually reading correctly and you don't have one reading off. Now, your EEVs should be about 30% open. If you have one that's at 100 or like really high, and another one that's really low, you got one chiller doing more work than another. So they should be pretty balanced. So if you have one that's not really doing any work, it is vapor locked with non-condensables. So that'll end up having a low EEV percentage because it's not siphoning any CO2 off the top of the vessel because all that non-condensables is stuck in the top of the heat exchanger. Now, when that happens, it locks up the top of the heat exchanger and you're no longer getting any flow through it. So now you have no load on the heat exchanger. So easy way to fix this, you shut the refrigeration off to that heat exchanger and you vent the CO2. And I'll usually go for like 2-3 minutes. Then I'll stop. Then I'll do it again, vent it again. Then I'll go for like 30 seconds and stop. Then I'll vent it again. Now, then you'll start up the refrigeration again. And that heat exchanger should start flowing now because now you've cleared the non-condensables off of it. There's a tap on the top of it. That tap's going to be the highest. Once it starts spraying liquid out of there, liquid CO2 out of there, stop, then do it again, then stop, then do it again. You want to make sure once it starts spraying liquid out of there, you got all the non-condensables out. And then you could start that chiller back up again. Now it should have load on it. I've seen racks where, I walk up there and there's 3 compressors running. Everything's got good superheat. The superheat set point's real low. It's like 6 degrees, but, my EEV percentages are real low and somebody got non-condensables in the rack somehow. And once you purge out the chillers, that rack may load up to like all 6 compressors and be running like 80% load. So that's one thing to take into consideration when you're doing that.
So you were talking about the blockage before, and I honestly thought like if you have a high moisture content in the HFC or HFO refrigerant, that would potentially cause you to ice up. You know what I mean? Because basically that's kind of like how they make snow. Like on mountains, they'll use big air compressors and cyclone that air with some water. Basically making a venturi, and then that's going to create snow. Well, same principle, right? You have a decrease in pipe size, so you have an increase in velocity. So that increase of velocity with moisture, I had to think that would probably make a little bit, because we've had that problem at one of our sites, and it was actually one of the sites that I called you on, and it had non-condensables. It was freezing up on the heat exchangers. The unloader hadn't been working for a while. And once we got all those issues taken care of, the rack Cadillacs, it doesn't have any problems. But like I said, we had, we basically put high moisture dryers in it for 2 or 3 PMs, and it's actually cleared up. And I haven't had to do the blockage because some guy was talking to me about it and saying that he has an issue with it. And, he was actually stripping off all the insulation and heating it with a torch. I'm like, why? Just close off the suction line, override the EEV 100%, let that pressure rise up past freezing point, whether it be 48 degrees or whatever, and then slowly, open up the valve back up after you reset the expansion valve back down to 0.
Yeah, that's a great way to do it too. So yeah, I mean, it very well could be moisture. I've only had it happen on 1 or 2 racks, and I've had it from other branches. I've had guys call me and had the same thing. I mean, we drilled the hole on the side because we thought the heat exchanger had it was in the beginning. Thought the heat exchanger had a block. The heat exchanger was too small, so we ended up piping a bypass around it, and we were drilling into the headers when we found the ice. Like the ice nuggets, like it started. I was using a unibit and it was pulling out white stuff, and I'm like, "What is this?" And then all of a sudden, like I got the hole big enough, and I stuck my finger in there, and here's like an ice nugget. But that is a huge problem, and I've gone out of state to go look at a rack, and they were having issues on. And the first thing I look at, I see the 10, 15 pound drop on the heat exchanger, and I'm like, I know right away there's nuggets in there. And I think a lot of it comes from poor service.
So I've seen someone showed me some pictures of a rack that they were having issues with, and they actually cut the heat exchangers out. Like it was so bad, like they tried what I told them to, and they actually had to install, a small bypass, just to bypass some of that refrigerant because it was so restricted. Even after they tried, doing that, and the little tubes that were in there, little 5/8 or I think they're tinier than 5/8. They're tiny, but anyway, so they were actually crushed from the inside out. The only thing I can think about is like liquid hammering or something, like someone opened up a valve, too far or something too fast.
Yeah, it's another thing. Another thing with these controllers, I mean, a lot of them had some older valves in them. Generally, if you get a valve failure, or if you're having a heat exchanger that's not opening the valve up, generally it's the valve. I've only had one of these RCC controllers fail, but generally when people write them up, the EEV itself has failed. So just keep that in mind. And I'm just going to let you guys know, if you have a failed valve, it'll run on one very poorly. You're not going to maintain ice cream case temps. You're going to be like, you get the CO2 down to like -2 degrees. But when you go to cut that valve out, that heat exchanger is going to be loaded with oil. So just keep that in mind. Cut the valve out with a pair of tubing cutters. Do not burn the valve out. I almost caught a whole rack house on fire doing this. So yeah, it just kept coming and coming and coming, and it was just spraying. Like I took the motor off, and I was just going to swap the motor, and then I realized the threads were different. Well, like as I turned around, all of a sudden it was like an oil geyser. It was just everywhere. It was bad. And of course, it was hot, and it was a Friday, and next thing you know, I'm covered head to toe in oil, and I hated my life at that point, and the parts guy for not getting me the exact same valve. But yeah, that's one thing to go ahead.
You know what's even worse? So the rack that we got, it looked like it had the old Sporlan SMS controllers in there, which I don't know if anyone on here is aware like how those work, but basically there's 3 lights telling you that there's a problem. So unless you have the laptop, the dongle, and that actually it's an infrared dongle that how it communicates, rip it out, throw in a Sporlan superheat controller and be done with it. Because at least with the Sporlan superheat controller, you have a display, you have all the PID controls, that you can set. With the Sporlan SMS controller, you're basically kind of screwed. You know what I mean? Unless you have the software, which is old, and I don't even know if you can get it anymore. I have it because I save everything. But yeah, if you have an old SMS controller, rip it the hell out. It's just going to cause service problems for the other guys that, that don't have any visibility to it.
I've never been actually able to physically make that work on my computer.
Really?
Like the dog, I've never been able to connect to one of those. No matter what computer I tried, like I gave up. Like if I see them, I rip them out.
Like I said, they take all the same pressure transducers and temperature sensors as a Sporlan, because they say Hill Phoenix on them, but they're basically a Sporlan controller. They're basically a Sporlan controller with blinky lights. Hey guys, I want to take a break and talk about Westermeyer, one of our other sponsors. Today's episode is sponsored by Westermeyer Industries, the leader in oil management and pressure vessels for the commercial refrigeration industry.
Yeah. So let's go over like servicing the actual CO2 side. If you guys got to isolate something. So everybody's afraid of making dry ice. Dry ice is not as big of a problem as people think. Okay. Dry ice, if you make dry ice, okay, the easiest way to get rid of dry ice is to raise the pressure.
Eat it.
Yeah, you may die, but I mean, so if you make dry ice in something, meaning you isolate it and you blow it down too fast, generally when you're blowing down something, you want to shut the supply off, especially if it's the case. I isolate the supply. I'll go through it and defrost. And I'll let the heaters come on and I'll let them heat up the coil. And then I'll shut the return after like 15 minutes. And then I'll blow it off and it'll be all vapor. That's the easiest way to get rid of all liquid in the coil. If you're isolating the case, every case has its own ball valves. So that is the easiest way to isolate it. If you're going to service it and you're going to do that, make sure you take the coil off and use a magnetic plunger. So that way you could, if you got to change a solenoid or something. So these solenoids are special CO2 solenoids most of the time. They're XPS valves. They're designed for the fluid flow for CO2. So just make sure you're not just putting like an ME6 in there or an ME9. Make sure you're actually using one of these XPS valves. They're designed to close at a lower differential, pressure difference across them, and they have a beefed up spring inside of them to hold them back. Now, when you're looking at these CO2 ball valves, you're going to have check valves around them. So if you were to shut the supply and the return, and the pressure started increasing inside the line set and the coil, it's going to check back into the liquid. It's going to check back towards the rack. So that way you can't ever overpressurize the line. It's there for your safety. Now, we've had this, we did like 12 of these stores up here, and the guys were pretty good after store number 2, where we learned if you put the valves in backwards, you can't shut them off. And then you got a real problem. And there's still stores out there where the installers didn't pay attention to where the check valves are going, and now you've got to blow off an entire line set. So an entire loop, which that becomes a problem because it takes forever. So you want to make sure you're pulling good vacuums when you're doing this stuff too. So pull a nice, good, deep vacuum, because you don't want the moisture inside the CO2. Because if you get moisture inside the CO2, it makes carbolic acid, and it starts eating everything.
I didn't know that it made carbolic acid. My bad. So what he was talking about before, it actually, the suction on this, it doesn't actually usually say suction on there. It usually just says return, because like he said, it's called a wet suction, basically a little bit of liquid, a little bit of vapor coming back. There is no expansion device in these things. All there is basically just a distributor, and that's just to distribute the refrigerant evenly. Sometimes you won't even have an actual distributor. Sometimes it'll just be one line in, one line out, kind of, comparable to like a glycol coil. You'll also notice on these coils that there's a lot less copper, a lot less U-bends on these units because the BTU exchange is so high for CO2, not as much copper is actually needed. And like you said before, there's usually always going to be a liquid line solenoid for temperature control because we're not going to put any EPRs on this stuff. Also, we on some of the bigger boxes, sometimes for a major shutdown or shut off of the system, they might have a actuating suction ball valve on there to actually close it off. When you do have some sort of failure on these systems, on any kind of CO2 system, basically they're on a timer. So they'll shut down, like if you were go off on high vessel pressure because of a problem with the DX side. When I say the DX side, I'm talking about the HFC or HFO. If you have a problem with one of those systems where the pressure of the vessel goes up, it actually shuts down every single circuit on there. And then once the pressure gets low enough where it returns to a normal status, it'll start energizing circuits one at a time, usually timed anywhere from 3 to 5 minutes. Novar does theirs on, basically within their programming. Usually with CPC, you'll see a flexible combiner, which basically takes, each enable for every single case controller, and basically we'll start those one at a time. You want to add anything?
Yeah. So the only, so for Walmart, for example, the only time you're going to see something different besides a solenoid is they use a Danfoss Orphist solenoid inside the coffin cases, because what we were having in the beginning of this whole thing, we were wearing out the Sporlan solenoids from cycling rapidly. Like they were cycling like hundreds of times a day for the medium temp, dual temp coffins. So they ended up taking a Danfoss valve and putting it in parallel with the Sporlan valve. So the normal XPS valve would run for low temp, and then in medium temp, they would shut the Sporlan solenoid, and they would use the Orphist Danfoss solenoid to kind of slow down the flow. So that way, during medium temp, it was using this Orphist solenoid, so it didn't get as much flow. So that way, they weren't cycling as much for medium temp applications. And then, so let's go over on how to charge this. So this is probably one of the easier ones to charge. Now, there is a switch on all these racks. I've never seen one without it, especially with the Hill ones. I know there's some Kaiser stores out there. And just pray to God you don't have a Hussman store, because they tried a couple and they were disasters. Hussman's never really had a good run at CO2. They're always late to the party, it seems like. So there is a switch on there that says Defrost Shutdown. Now, when you flip this Defrost Shutdown switch, it kills all the defrost in the store, as like it says. And then it also kills every solenoid and every fan in the store. Now, what this is going to do is this is going to cause all of our CO2 to migrate back up to the vessel. Now, the way I charge this is when the last compressor shuts off, meaning all the load is gone off the CO2 side. When the last compressor shuts off and the vessel's down to like 180 pounds, which is your shutdown for your compressors, you should have an 80% light on. Now, you should have lights on here. You should have like a 15%, 25%, a 50%, and an 80%. And then there should be some racks have a 90% high, but you should be at 80% solid. I usually watch it for like 3 to 5 minutes. If it stays solid, then I know my charge is good. Now, running, you're going to be anywhere from 15 to 25%, but it's really hard to gauge because it depends on the load downstairs and how many boxes are cycling off. So in order to keep away the nuisance 15 alarm low limits, I always pump it down. It takes like 10, 12 minutes to pump it down, and then I will charge it from there. At the top of the vessel, you're going to have a suction filter housing with 3/8 taps going to it, and that's where you're going to charge at. So you're going to go through that suction filter. It's got a liquid core in it, and you're going to filter the refrigerant through there, and you're going to feed into the vessel. Now, you do not need a regulator. I just let the tanks go full wide bore, because you're going from a small tank of high pressure into a gigantic large vessel of low pressure. So that tank just takes it. So you have that rapid expansion. So when I hook up the tanks, I usually do like 3 or 4 tanks at a time. I have like a nice manifold I made, and then I'll valve them on and off, and I'll have somebody downstairs filling while I'm watching. It takes 2 guys, or else you're going to be running up and downstairs a lot. So I'll sit there and I'll watch the level while the other guy is feeding tanks in, and then once we get that 80% level, I'll stop charging, and then I'll let it sit for a minute, and then I'll flip the switch and then let it go, and it's going to go through its startup sequence. Go ahead, Brett.
So when you do a startup on CO2, I was always told that, like, if you're breaking it off a vacuum, they do sell CO2 just vapor cylinders, correct?
Yeah. So like when I start up a rack, like we're doing a lot of transcritical startups right now. When I first start up the rack, I'll bring it to like 130 pounds, 150 pounds with vapor tanks.
Mm-hmm.
And if you don't have vapor tanks, which is what I had to do on the last startup,
turn them upside down.
Rack, I had to turn them upside down. And I'm just going to tell you this. And if you could only get vapor tanks. So we had another job where Air Gas delivered me out 41 vapor tanks, and they could not get liquid CO2 tanks with dip in them. I mean, I was very, very, very upset about this, but I ended up having to tip the tanks over, on their heads. It's not safe whatsoever doing that, but it'll get the CO2 out of them. Now, and these tanks only hold about 50 to 60 pounds of CO2. If you're really desperate, I mean, you're going to have to heat up the tanks with a torch a little bit. Air gas is not going to like that. But like, I mean, if you need to get every bit out of there, you need to get every bit out of there. So you want to get that vessel as low as you can while you're charging, so you get more CO2 out of those tanks. Those tanks are very heavy, so be very careful. I mean, they're like twice as heavy.
So those tanks are, because of the pressure. So remember, CO2, I mean, any refrigerant, right, is going to acclimate to whatever pressure, to whatever temperature, that you're at, right? So at 87 degrees, it's 1,044 PSI. So, the tanks have to be, I think, double walled. So a normal 50-pound cylinder for CO2 feels like probably like a 125-pound cylinder. So having to try to turn those, on upside down, I'd get a hernia. There's no freaking way. I'm not doing it. I'll try whatever I have to.
Yeah. Another thing we've done is like a lot of times ours come in the back of a pickup, and we'll just lay them down the pickup and just jack the end of the tank up a little bit. So that way it's just got an angle on it. As long as it's got an angle on it, you're good. That's a lot easier to do than standing them straight up. So I'll do that a lot on startups. Like if we have bottle racks and they're vapor only, I'll tip the bottle rack on its side, and then we'll put a jack underneath it, and we'll jack up the bottle rack on one end and let them all tip down, and then we'll get the CO2 liquid out of them that way. But that's another easy way to get it out without killing yourself. But yeah, don't let one of those tanks go wild either. I mean, I use a normal charging hose, a black refrigerant charging hose. Just don't trap liquid in it. I mean, as long as you don't trap liquid in it, it's not going to blow apart. I've been using the same charging hose for the last 7 years, and I've yet to blow it apart. And I've probably put, I don't know, 30,000 pounds of CO2 through this thing. I mean, guys are on here saying you can't. I mean, you can. You just got to use your brain and don't trap CO2 in it. I always, turn the rack on for the rack pressure on first, let it bleed back, and then I'll open the tanks up and open them up slow so I'm not blasting the hose. But I have yet to break a hose. You can get a hydraulic hose made. I mean, we've had that done before. I mean, if you're going to do that, you might as well get a 5/8 hydraulic hose. It goes real quick. So the faster you get the CO2 in, the better. Don't use a regulator. I've seen guys using regulators. It takes a tank of CO2 to go into one of these subcritical liquid pump systems should take no more than 3 to 5 minutes to feed an entire tank in. If it's taking any longer than that, you're doing something wrong.
So the whole time while you're talking, I'm envisioning next week's podcast. We're starting to talk and trying to see what we did last week. And he's like, you never know what happened, man. Last week I was charging and that pose just freaking blew up. I don't know what the
Yeah, I've yet to blow that hose up. So in the end, it looks kind of sketchy. So those hoses are expensive. But I've yet to break it, put it that way.
tool replacement.
Yeah, it's got a lot of miles on it. It's had a lot of refrigerant going through it, and she's yet to fail yet. So when these racks do go down, I mean, depending on how warm or cold it is outside, I mean, it depends on how the reliefs are going to blow. I mean, with you guys in Texas, you probably got like a half hour, and the reliefs are going to be popping. So, yeah. I mean, with us up here in the wintertime, I had a store that was down for 4 hours with no power, and we didn't lose 1 ounce of refrigerant or CO2. Like, it just stayed. It was cold enough on the road, it stayed.
So I've seen a bunch of Cascade racks that have auxiliary side condensers. Basically another, raised by heat exchanger. That's basically, in case you have a failure on the DX side, right? Have you ever seen that on a pump liquid system? I never have. I mean, no.
There is a chain up here supposedly doing pump liquid. I have yet to see them be in this chain, but supposedly they're putting auxiliary units in. I mean, it all depends on what the customer wants to spend, and Walmart didn't want to spend the money at the time on the generators and everything else. So, it comes out of somebody else's budget.
No, but you think for how much refrigerant they would have saved? Like we have one store where basically we have to have X amount of pounds of CO2 on hand, because this store, if it rains, if someone looks at the transformer, the store ends up going down. It has nothing to do with the refrigeration. They just have crappy power in the middle of Dallas.
We have two of them that are like 8 minutes apart from each other, and they're on the same grid. So when one goes down, the other one's down too. So they're both blowing the relief. And so you just know when you get the power out, I mean, you're going to need CO2. Generally, if you're getting a 15% warning or 5% warning, it's 300 pounds at these Walmart stores you need to bring it back up to where it needs to be. So if you're getting a 5% warning, like low liquid lockout, and you're locking the pumps out every once in a while, you need 300 pounds of CO2. Now, remember, that's not 3 tanks. That's 6 tanks. So, because you get about 50 pounds each. So generally, it's about 6 tanks to bring it back up to where it needs to be. And then another thing, like your high leak points, you're going to want to check your ball valves in your store. I don't know how many Mueller ball valves I found, just blowing liquid CO2 out of them in the ceiling or somewhere else. So just really keeping the seals failing them, just either nylog them, or I end up throwing a retrofit cap on them. I mean, usually the retrofit cap will stop them from leaking if you can get it on there. But generally, that's where I see most of the leaks at, or on the Mueller ball valves in the store, or on the loops, or on top of the walk-ins. So if you see yellow stains, I mean, just keep your eyes open. And then the leak detectors, if you got the old school D-Tech, you might as well just shoot yourself in the face, because that thing is just the worst leak detector ever. Like, I think I found more leaks in my eyes than that thing. But the Stratus has been like perfect for finding CO2 leaks. I mean, they really got that thing taken care of, and it actually works great.
So one thing about leak detection, so what you can use is an ultrasonic. So when I did industrial air compressors, that's how we actually found air leaks. We did an air audit and actually walked the store. Ultrasonic is basically, it's picking up sound. So you can actually point it at up to 300 feet away and you can actually hear leaks. It's perfect time to leak check. If you have a store that's blowing CO2 and power's out, no one's in the damn store, and they're looking for stuff anyway at that point, making sure that all your release is settled out. You can use an ultrasonic to try to find some of the leaks. What's your opinion? Because I've told guys, be it the fact that you have pump liquid, right? So, if you have CO2 cylinders inside the store and your rack happens to be up on the roof, you agree or disagree with charging at the case?
Oh, you can. I mean, there's nothing wrong with it. All of our stores have charging lines, though.
I'm just saying, I'm late and old, so.
Well, every store that we built, we put charging lines in. It was not on the prints. I mean, we did it anyway because we were servicing those stores. 100% servicing those stores. And then they actually paid us to come back in and put charging lines at the 3 that we didn't do. They paid us to put charging lines in at them because it's safer and it cuts down on the thing big time. And then you don't have guys charging on the sales floor, because everybody knows if you rope off an aisle and you're in there charging and you have like a line drop down from the rack house and it's in a chip aisle, some idiot is going to walk right past the caution tape because it seems to attract the idiots, and they're going to walk right into where you're charging. And then if something happens, then it's your fault, and hose blows off, or Old Faithful finally fails. So I mean I would push them to put a charging line in. I mean, it to me it's a safety issue. I don't want my guys charging CO2 in the middle of a sales floor while it's open.
I get it.
But yeah, you can't put it in a case. Just little advice here. Pull the Schrader. You can't. Don't put it through a set of gauges. It's going to take forever. So pull the Schrader. But if the Schrader gets stuck in the core puller,
walk away.
Don't shoot it out like you would like normally. Like if you just it's stuck, because it's coming out a lot faster, and it hurts. So I don't know how many I probably shot across the store like that on accident. You think it's got to have 50 pounds on there, and it's 300 pounds. You're gonna have a bad time.
Yeah, especially if the bottom piece breaks off in there.
Yeah, so that was a pretty good overview of liquid pumped CO2. Next time we're going to go into cascade CO2, and we're going to start introducing compressors and other components. And after cascade CO2, we'll jump into transcritical CO2. I mean, that's definitely going to be a two-parter, because now we're going to introduce hot gas defrost and some other stuff in there. So thanks for listening, guys. Have a nice night.
Later, guys.